everyone, my name is Fernanda Castellanos and today I'm gonna talk about the one-dimensional motion with constant acceleration. First of all, you have to know what is gravity. Well, gravity is the force that acts toward the center of the earth. This means, for example, when you have an object and you throw it downwards, it goes directly to the ground. Now I'm gonna talk about three kinds of accelerations. Free fall, the vertical throw directed downwards, and the vertical throw directed upwards. Free fall is just when we throw an object downwards, just like that. It doesn't have an initial velocity, so we assume that it's zero. Just the final velocity and the position are increasing, but negatively, because the gravity is going negative, so it's minus 9.8 meters per second. And in this way we know that the gravity is attracting the object through the ground to the center of the earth. For free fall we have these formulas. H is the height, so it can be replaced with y in every formula, but it's the same. Now I'm going to show you how to solve a problem from this topic. For example, the problem says if we have an object in y-axis equals to 0 when time is equal to 1 and the ball is released from rest, find the final velocity and its position. Knowing the problem, we need to find a formula to substitute the values. In this case, we have the final velocity equals to initial velocity plus gravity times time. But it says from the rest, so the initial velocity is equal to 0 automatically. Now we substitute the initial velocity equals to 0 plus the gravity, which is minus 9.8 meters per second to the square, times time. And now we have the result minus 9.8 meters per second to the square. Now they are asking us for the position, so we use the formula h equals to initial velocity times time plus 1/2 of gravity times time to the square. We substitute the values 0 times 1, which is equal to 0, plus half of minus 9.8 meters per second times the time 1 to the square. This gives us the result minus 4.9 meters per second. In this case, we assume that the object is thrown directly vertically downwards. So we can assume that the initial velocity is negative and the initial position is equal to 0, so the position and the final velocity is always increasing negatively. Now an example of solving a problem like from this topic is if we have the same ball that we used in the previous problem, and now we have an initial velocity of 2 meters per second directed downwards, we need to find its velocity and its position. Now, having the problem, we have to identify the data they are giving us. In this case, they are giving us 2 meters per second in the initial velocity directed downwards. So they are asking us for final velocity, and now we have to find a formula to give us the final velocity. In this case, it's final velocity equals to initial velocity plus gravity times time. In this case, the initial velocity is not equal to 0. It's equal to minus 2 because in here says that it's directed downwards, plus the gravity minus 9.8 times the time, which is 1 again, and we have the result that is minus 11.8 meters per second. Now they're asking us for the final position. We have the formula height equals to initial velocity times time plus 1/2 of gravity times time to the square. We substituted minus 2 meters per second times time plus 1/2 of minus 9.8 times 1 square. That gives us minus 6.9 meters. In the third case, the object is launched vertically up, so the initial velocity is positive and it's decreasing until the top where it is 0. So then it starts falling down until it reaches the initial position where it could be falling down or it can be catch. That's all for today. Thanks for watching.